All right, hey there, this is Mrs. Chabot. This is for my intermediate algebra class. At this point, you should have completed the practice problems for sections 5.1 through 5.3, so you should be comfortable working with polynomials in general, adding like terms, adding polynomials together, subtracting polynomials, and also you should be pretty comfortable with exponent rules. So I just want to review a little bit of what you saw in those sections. So when you're multiplying the same base together, x cubed times x squared, you're multiplying the same base, so you keep the base and add the exponents to get x to the fifth. If you are taking something to a power raised to another power, you keep the base and multiply the exponents. So x cubed squared would be x to the sixth. So what about x cubed plus x squared? What could I do to simplify x cubed plus x squared? Well, you should be thinking nothing because those are not like terms. Okay, so while we can multiply the same base together, the only time we can add terms together is if the variable part is exactly the same. So x cubed and x squared are not like terms. Okay, so there's nothing we can do there. But x cubed plus x cubed are those are like terms, so I can add those together to get 2x cubed. Remember, when you're combining those like terms, you add the coefficients out front and remember to keep the variable part exactly the same. Okay, so you should have practiced multiplying terms together in 5.3, but that's going to be an extremely important skill for the rest of the semester, and if you continue to take algebra after this. So let's take a look there. I can multiply the 7 and the 4 together to get 28, and I can multiply the same bases together. Y squared times y to the fifth gives me y to the seventh. So that's how I multiply terms together. So if I want to multiply these two terms together, I'd multiply the coefficients, -1 times 10, to get -10. I'd multiply the same bases together. So I'd multiply a squared times a to the first to get a cubed. I'd multiply b cubed times b squared to get b to the fifth. And I'd multiply c times c to the 12th to get c to the 13th. If you are not 100% comfortable with multiplying terms together, you need to go back into section 5.3 and keep practicing these similar exercise after similar exercise until it's just super easy. Okay, because I want to add on, I want to be able to multiply 3x times 4x plus 7. So what do I need to do to multiply there? I need to distribute. If you are still not super comfortable, you can write the distributing step, 3x times 4x plus 3x times 7. But I'd like you to eventually be very comfortable multiplying terms together where you don't need to write this. You would just say 3x times 4x, oh, that's 12x squared. And 3x times 7, okay, that's positive 21x. I'll write plus 21x. Okay, great. Once I can do that, I can move on to something like x plus 2 times 3x plus 1. A general strategy for multiplying polynomials together is essentially to distribute twice. So I would take this 3x plus 1 and distribute it to the x plus 2. So I would do x times all of 3x plus 1. And then I would take this plus 2 times all of 3x plus 1. So I've distributed to get rid of the first set of parentheses, and then I would distribute again. X times 3x gives me 3x squared, plus x times 1 is x, plus 2 times 3x is 6x, plus 2 times 1 is 2. And at this point, notice we have like terms in the middle, so we would keep the 3x squared. 1x plus 6x is 7x, plus 2. Okay, so that's all done. Okay, so I could apply this to any product of polynomials. So I'll apply this same strategy here to multiply a binomial times a trinomial. Okay, so I'm going to distribute first to get rid of that first set of parentheses. So I'm going to take this 7x times all of 2x squared minus x plus 1. And then also take that -2 times all of 2x squared minus x plus 1. Distribute again to get rid of the parentheses, giving us 14x cubed minus 7x squared plus 7x, and then minus 4x squared plus 2x minus 2. Notice we have like terms here as well, so you'd keep the 14x cubed. Adding negative 7x squared minus 4x squared will give us negative 11x squared. 7x plus 2x gives us 9x minus 2. Okay, so notice when we multiplied a binomial times a trinomial, we end up with 6 terms before simplifying. Okay, so that pattern will hold if I were to multiply 3 terms times another 3 terms. I would end up with 9 terms. Each of these 3 would get distributed to each of these 3, so we'd end up with 9 terms before simplifying. Okay, so that's the general strategy. Okay. All right, but this type, where we have a binomial times a binomial, like we saw in the previous example, example A, comes up so often that we want to all do it in the same order. So we're going to make sure each of these 2 terms gets multiplied with each of these 2 terms, and the order we'll do that in is called the FOIL method, which stands for first, outer, inner, and last. So first is referring to the first 2 terms. So in this case, it would be x times x. Outer is the product of the outermost terms. So I would do x times 5. Inner is the product of the innermost terms, which is negative 7 times x. And last is the product of the last 2 terms, which here would be negative 7 times 5. Okay, so x times x is x squared. X times 5 is 5x. This is just negative 7x. And negative 7 times 5 is negative 35. Okay, so notice that each of the first 2 terms did get multiplied with each of the other 2 terms, and it gives us x squared plus 5x minus 7x minus 35, and finally combine your like terms. All right, so we get x squared minus 2x minus 35. And then I have a couple other examples before you get to the MyMathLab video. Okay, whoops. All right, so last example I'm going to do with you guys are these. Notice we are multiplying a binomial times a binomial, so the FOIL method is appropriate. So I would do first times first. 4x times x is 4x squared. Product of the outer, 4x times negative 6, gives us negative 24x. What's I up to? Inner, negative 3 times x gives me negative 3x. And the product of the last, negative 3 times negative 6, gives us positive 18. Finally, combining like terms, we get 4x squared minus 27x plus 18. Okay, so that's our answer there. And let's do one more together. Here I'm multiplying a binomial times a binomial, so the FOIL method is appropriate. So we would start by multiplying first times first. 6x times 2x gives us 12x squared. Outer gives me negative 6xy. Inner, 5y times 2x gives me plus 10xy. Notice I'll write xy instead of yx. It's the same thing, but this way they're in alphabetical order, and these 2 terms now look like they have the same variables, which they do. And last times last gives us negative 5y squared. Again, we have like terms in the middle, so we get 12x squared plus 4xy minus 5y squared. Okay, so the reason I took some extra time to go over these extra examples for you is because this method is going to be so important. And make sure you practice this type in 5.4. Do extra if you have to, because when we get to section 5.6, You are literally going to have to be able to do this forwards and backwards. So you'd be looking at an expression like 4x squared minus 27x plus 18, use what you know about FOIL, and manage to rewrite it as this product, 4x minus 3 times x minus 6. So if you're not comfortable going forwards, you will not be comfortable going backwards. So make sure you do a lot of practice with those in section 5.4. Okay, and then Aline Martin-Gay is going to do some additional multiplication examples in 5.4, as well as some special types. So make sure that you do continue with section 5.4 in the My Math Lab video before doing the practice problems. All right, I hope that this was helpful. Have a good day.